Hi, welcome to the video solution for Edexcel Physics. This is Edexcel IAL Unit 6, January 2021. So let's start. Question number 1. A ball rolls along a U-shaped track. The ball oscillates in a vertical plane as shown. So this is the ball moving left and right in a vertical plane. So describe how the time period of the oscillation should be measured to make the reading as accurate as possible. Generally, this question comes for 1 or 2 marks, but in this question, they are saying 3 marks. So you need to include at least 3 points. So if you see the diagram, in order to find accurate time, first of all, we need to have some position with reference to which we can start or stop our stopwatch. So we should measure the center point, and we can take this center point as a reference point, and then we measure the time for more than one oscillation. Generally we take 10 or 20. So we measure the time t for n oscillation. And then in order to find the time period, we need to divide the measured time with the number of oscillation, so we can have the time period. And then if we need to improve our reading, so we repeat the same procedure and we find the time, and then we use the mean value. So that's how we can improve our reading. So that's how you can write. You can rephrase this answer in your own words. So you need to measure the time for number of oscillations and then divide the time for time with number of oscillations, so you can have a t. So t is equal to t by 10, and then you repeat the whole procedure so that you can have a more accurate reading. Part B is describe how a single measure of D should be made accurately. So D is basically, if you see the diagram, this is a horizontal distance between the two ends of the tube or whatever the object this thing is, or U-shaped track. So this is the horizontal distance. So we will use a meter rule, and the meter rule, if you wish, you can draw the diagram, and then this meter rule should be horizontal. But in order to keep the ruler horizontal, we can use a spirit level, and this is the picture of a spirit level, and this spirit level has a bubble inside, and the position of this bubble tells us whether the object is leveled or it is not leveled. So if this bubble is at the center, like right now, so this spirit level is exactly horizontal. So we put this spirit level above the ruler at the center or at the corner or both corner. If we put a spirit ruler and we adjust the ruler so that the bubble inside remains centered, and if the bubble is at the center, then the ruler will be horizontal. And another thing is, we should, because we are this is analog meter, and we are using our eye level, so our eye level should be perpendicular to the reading in order to avoid or reduce parallax error. Part C. A student determined the time period t for a different value of the distance d. She obtained the following results. This is d, some measurement distance 0.235 and 0.335 and 0.445, and the time period for particular distances. She predicts that for these oscillations, t is proportional to root d. We read it t proportional to square root of d. Show that her results are consistent with this prediction. Remember, if two quantities A and B, if these are proportional, then ratio between A and B, or A divided by B, must be constant. If this ratio is, or this relation is valid, then A divided B must be constant, and that's what we are going to check, whether the ratio between these two and these two and these two are constant, then this prediction will be valid. So let's check. You can say that T is 0.78 divided by square root of D. So square root of D is 0.235. You use your calculator, your answer will be 1.609, which is approximately 1.61. And then you do the same thing. So you need to show these calculation because there's nothing to do, there's nothing else we can do. So 0.94 divided by square root of 0.335, and the answer will be 1.62. Similarly, you can do 1.09 divided by square root of 0.445, and then answer will be 1.63. So you see that this is approximately 1.6. So of course ratio between T over that is T over root D is a constant. So of course prediction is valid. So you just write at the end, yes, the given prediction is valid or consistent with the result. Don't forget to give your final conclusion. Question number 2. Two identical capacitors were connected in series and charged. They were then discharged through a resistor. So we have a two identical capacitor connected in series, and they were charged and then discharged through a resistor. A student investigated how the current in the resistor varied as a capacitor discharge. So we need to study between the current I and the in the resistor varied with the as the capacitor discharge. Okay, draw an appropriate circuit diagram for this investigation. It is a typical circuit diagram, charging and discharging circuit. But here we have to use two identical capacitor in series. So you can use this is one capacitor, another capacitor, and then you can connect an ampere meter here. These are two-way switch. The left side or the right side, it's up to you. Generally we take this. So this is your power supply. V and C and C, or you can give some other symbol. And this is A, B and C terminal, and this is an external resistor R, and then it goes to the ampere meter. So this is a typical circuit. If the B is connected with A, then this is a discharging circuit, and then B is connected with C, this is discharging circuit. So that's the circuit diagram of 3 marks. State 1 safety precautions the student should take. One of the most important precaution or safety precautions in charging capacitor is the voltage of the power supply should be within the limit of the capacitor. If V exceeds the limit, then it is possible that the capacitor explodes. So we should use appropriate power supply within the limit of capacitor voltage, so that capacitor does not explode. This is one of the precautions. Question, part C. The student had a stopwatch. Describe how a student should determine an accurate value for the total capacitance of the capacitor. So the idea is a student has to use this circuit, and what should he or she do so that the student can find accurate capacitance of the circuit, the total capacitance of the circuit. So the idea is, first, say the overall the conclusion or the purpose is we need to charge the capacitor, and then we allow discharge the same capacitor. But because we need to measure the time for discharging, so we need to first select the appropriate resistors value, so that capacitors take some time to discharge and we can measure some current. If we take a small value of resistor, then the capacitors are going to discharge very quickly. We cannot measure the time for discharge. We cannot measure the amount of current. So first of all, we select the appropriate value of high resistance, so that the time of discharging can be increased. And then we can put next step, we start the investigation. The capacitors are allowed to charge directly from the voltage, making sure that the voltage across the capacitor would be equal to the voltage of the power supply, or in other words, we make sure that capacitors are fully charged. So after selecting resistor, connecting the circuit, we allow the capacitor to charge, and after we change the switch to C or to discharge, but before discharging we put a stopwatch alongside the ampere meter, so that time and the current can be measured simultaneously. So after placing a stopwatch near to the ampere meter, and then we allow the capacitor to discharge, and of course we would have initial current, and we keep noting down the time, equal interval of time, and the corresponding current, and then we can have a value of number of readings for time and the current. So we can plot a graph of log of I against time, which will definitely be a straight line with negative gradient. And if you find the negative gradient, then gradient M will be minus 1 upon RC. If you recall the relation between log of I and T, so ln I is equal to minus 1 upon RC T plus ln I naught. This is the relation between current, log of current, and the time. So this is the gradient. So gradient of this line will be minus 1 upon RC, and clearly capacitance can be found by minus 1 upon R into 1 upon M, or 1 upon gradient, or you can say minus 1 upon R into M, or gradient. You can write the gradient if you don't want to use M. If you're confused, M is the symbol for gradient, so you can say M is gradient. So that's how you can explain the whole procedure of starting experiment and ending and determining the accurate capacitance value. So you can write the whole procedure just like that. Is just an example. This is what comes in my mind, and you can rephrase, you can manipulate the answer in your own words, but make sure that you must include all the points. Part D, the student repeated the investigation but used a data logger instead of a stopwatch and ammeter. Suggest why using data logger would improve this investigation. Of course, data logger, because we are dealing with the discharging procedure or discharging of capacitor, which is a very quick method. The capacitor is discharging quickly, so we can have time in seconds or some 10 to the power minus 2 seconds. But if we use data logger, we can have the data points even a small interval. So a small interval data can improve the best fit line. And of course, data logger is automatic measuring the time, so there will be no reaction time. So two advantage: we can have more data point to plot, so that best fit line will be improved, gradient will be improved, so value of C is improved. Next, we cannot have we can avoid the reaction time. Question number 3. When high energy electrons are incident on a sample of an isotope, a diffraction pattern is produced. The diffraction pattern can be used to determine the radius of a nucleus of the isotope. The relationship between the radius r of a nucleus and the nucleon number A is this: r equal to r0 r0 a to the power n, where r0 or r0 is the radius of a proton and n is a constant. Explain why graph of log of r against log of a can be used to determine a value of n. A typical question comes an exam, they give you some equation, some relation or general equation, and they ask you how can we use this equation to show that this equation can be rewritten as y equal mx plus c. But we have exponent here. We cannot, so in order to remove this exponent, we need to apply log. So log of r is equal to log of r0 into a to the power n. And on the right side, we have r0 and a. This is the product. And according to log rule or law of logarithm, we can write is log of r0 plus log of a to the power n. Finally, n is the power. It can comes before log. So we can rewrite log of r0 plus n log of a. And then finally we arrange this equation as log of r is equal to n log of a plus log of r0. So compared with y is equal to mx plus c, where m, which is the gradient, if you compare, then which is equal to n. So n is a gradient, or gradient is equal to n. And c, which is the y-intercept, is equal to log of r0. So this is just additional information I wrote, but this is the final answer. That's how we can use this equation to find the grade n as a gradient. So log of r is equal to n log of a plus log of r0. Remember these three steps, you can skip these two, the second and the third step, if you are okay with your mathematics. It depends upon you. B, the table shows the value of R for some different isotopes. So we have hydrogen 2, helium 4, beryllium 9, carbon 12, oxygen 16, magnesium 24, and we have nucleon number and R. And this is FM, Fermi meter or femtometer. F, this is 10 to the power minus 15 just additional information, but here we don't need it. Plot a graph of log of r against log of a on the grid. Use the additional column in the table to record your process data. You should not convert value of r to meter. That means we do not need to use value of femto. We leave number as it is, because we need to plot graph of log of r, log r, and log a. Remember, in your calculator you must use log, not ln. So log, log base 10. So once you do that, so first of all you need to fill these heading column, and then you take log of a, so log of 2, log of 4, whatever the numbers are you going to write here. So take log of a and write it here, and then log of r, and then this is r, log of r, log of these values, and you put all these numbers here. So use your calculator, you can find all these numbers, and if you do that, then the heading of this first one is log of a. Remember, a, this is a nucleon number, which is just a number, no unit. So log of a has no unit, and then value of log of a, and then second heading is log of r, and unit will remain same, fermimeter or femtometer, but log. And then you can have the first column, and then you can have a second column, and these are the values of the log. Now I want you to discuss the plotting graph, because I have many students, and some students also ask some key points in plotting the graph. So I thought that we should discuss, and of course this is a 6-mark question. So of course 1 mark for correct heading with the unit, and then correct values with the correct significant figures, and then rest of the mark is about the plot. So let's discuss the key feature of plotting the data. This is the grid given, empty grid, and this is a question that you need to do. So we need to plot a graph of log of r against log of a, and this statement is important, log of r against log of a. So before against we have a log of r. This is dependent variable, and this is independent variable. The reason is, when you select the axes, on the axis we need to choose the label. We need to label the axis. This is 1 mark thing. You need to label the axis with proper unit if there is some unit. If there is no unit, it's fine. But if there is a unit and you don't write, you will lose marks. So the first thing in plotting graph, and once you draw the axis, don't forget to label it with proper unit. In this case, if you see, we need to plot log of r against log of a, and on x-axis we always use independent variable, and on the y-axis we always use dependent variable. In this case, generally first column is independent variable, and the second column is dependent variable. So on the x-axis we will take log of a value, and a has no unit, so log of a has no unit, so you don't need to write the unit. But the second column on the y-axis you will label log of r, but with proper unit, femtometer. This is the first thing before. And after labeling, there is a thing that you need to label the axis. You need to mark the values here. So this is another important task, how to choose these number. So this is called scale, or scaling the axes. So we need to write, or we need to choose the proper scale. So the idea of choosing proper scale is you choose the maximum and minimum number. So for log of a, this is your minimum value, and for maximum value is 1.38. So your scale should start at least from 0.3 or 0.2 or 0.1 or 0. It depends on the space given. And maximum it should go to 1.4, 1.5, something like that. And for the second column, your minimum value is 0.19 and the maximum value is 0.53. So you can start with 0.1 and 0.15, something like that, and 0.55. This is something, the range of your values that you plot on the x-axis, y-axis. But the choosing scale is important. Remember, this is another key idea where you should, take care that you choose a sensible scale so that you can cover at least more than 50% region of the graph. So whatever the shape of the graph is, it is a line or maybe a curve, it should cover more than 50% region of the given grid. Like a blue region is a more than 50%. It may be a 60, 70, 80, it doesn't matter, but it should not be less than, it should not be 50 or less, in my opinion. 50, less than 50 is of course not acceptable. You will lose 1 mark. So you choose the scale, sensible scale, so that you can cover more than 50% region. So if you are plotting graph from the bottom left, so you can plot something like this. But it is possible that sometime you choose a scale, so you don't start your graph from the bottom, you start slightly above. So if your graph is slightly above the above region, so this is the region that your graph or your line should be. So this region is more than 50% of the given grid. This is acceptable. Or it is also possible that your covered region is this. So whatever the situation is, choosing a scale is important. You choose the scale, you mark these numbers on the axis so that you can cover more than 50% region of the graph. Now, after scaling, after deciding the scale or values on the axis, it is time to plot the graph. So at 0.3, whatever the 0.3 is, anywhere, maybe 0.1, 0.2, or maybe a 0.3, you need to plot 0.1. And whatever the 0.1 value is, generally what happens is students put dot. Do not, this is called blob. So do not put a blob. This is wrong, you will lose marks. Instead of blob, we need to put very small cross, something like this. Very small, so that you can have marks. So we do not put a blob for a point. Instead, we always put a cross. Finally, after plotting all the points, we need to put a best fit line or a curve depending upon the trend, whether it is a curve trend or it is a best fit line. Most of the time, it is a best fit straight line, but there is possibility of a curve. Okay, now let's discuss what is the meaning of best fit line. I am not giving you the statistical definition of best fit line. The easiest definition for us is, in general, the best fit line is a line that we draw on the graph so that all the plotted points are equally distributed around our line. This is important. It is not necessary that the line must pass through all the points. No. The best fit line is the line about which all the points are equally distributed. What is the meaning? Sometime it happens that when we plot a graph, all the points seems to be perfectly on a straight line. So you join simply all the points with a straight line and you say, yes, this is the best fit line. So you join all the points in a straight line, there's no worry, no problem at all. But most of the time when we sketch, we have points scattered from the line. Some points are above, some points are below. This is called a scattered point or a scattered plot. One most common mistake students generally do is they just join all the points like that, thinking that, okay, these are the points and we need to join them. No, we don't do that. We do not just, join all the points with some random curved line. If you do that, of course you will lose the mark. So do not join all the points. You will have to draw a straight line most of the time so that all the points are equally distributed. Now, second thing, students generally draw a line thinking that the line should pass through from maximum point. Like this blue line is passing through from maximum point, of course, but this is not the best fit line, because as per definition of best fit line, all the points are equally distributed. So same number of points above, this is above region, above the line, and this is below. So equal number of points we must have above and below. So we see that we have 2 points above the line, but we do not have any point below. So this is not a best fit line. Clearly, it is not a best fit line because we have a point below, but we do not have above. But we can have this as a best fit line. The reason is, the concept of best fit line is, if you see, we have these 2 points above the line. So, and these 2 points are below. So this distance and this distance are compensated, and this and this approximately, not, it should not be accurately, but so these 2 points are below, these 2 points are above, and of course these 2 and these 2 approximately same. So yes, we can say that this is the line about which all the points are equally distributed. So that's how we draw a best fit line. And after best fit line, we need to find the gradient, and we choose the 2 points on the best fit line to find the gradient using y2 minus y1 divided by x2 minus x1. So let's move on. So this is the value, these are the values, of course, we need to plot. So here we have axis, and I chose these values 0.3 to 1.38. So on x-axis I chose log of a, and starting from 0.1 to 1.3, of course more than 50% region is covered along x-axis, and minimum 0.19, 0.53, and I chose 0.1. So 20 boxes I chose 0.1, 0.2 until 0.5. So of course I can have you can see this is the region at least that I am covering, which is of course more than 50%. This is one of the scale, you can you can change it, but it should be more than 50%. Now we use these values. So 0.3 is 0.19, and again, when you plot, please, this is just a reminder, do not put a blob. So that's how you can put all the points using cross, and then the best fit line is this. So this is the best fit line. Now after that, we need to find the gradient. So in order to find the gradient, we need to choose 2 points on the best fit line. Remember, do not use the point given in the table or given values. Do not use those. Always choose points on the line. So I am choosing these 2 points. If you see here, this point and this point, the distance between these 2 points must be greater than half of the length of the line. What I'm saying, this distance let's call that distance d. Is just an example I'm giving you. You don't have to show all these things. This distance d between the 2 points must be greater than half of the length of the line, and half of the length is approximately this. This is the half of the length. Clearly this distance is greater than half of the length. So of course we choose the point as maximum as far as possible. So these 2 points I'm choosing, and then these are the coordinates of these points. You can choose it from x-axis and the y-axis for both points, and then you must show the triangle. Don't forget to show the triangle that this triangle you are using. Now let's use, and then you can find the gradient. So m gradient is equal to y2 minus y1, which is equal to 0.5 minus 0.225 divided by x2 minus x1, so 1.3 minus 0.42. Now gradient would be equal to 0.3125. So 0.31. So n is the n as per equation, n gradient is n is equal to 0.31. So this is the value of n. Determine the value of r naught and hence state the mathematical relationship between r and a. So in order to find r naught, remember our equation was log of r is equal to n log of a plus log of r naught, and this is log of r naught is a y-intercept. Y-intercept, and that's what we need to do. So this is the graph that we plotted. So we find the y-intercept. So we extrapolate this line with the dotted line or whatever you can do, and you can find this point as a log of r naught. So according to graph, log of r naught is 0.1, and you need to find r naught. Remember r naught. So you need to remove log. And how do we remove log? When you remove log, so you take anti-log, and effect of anti-log is r naught anti-log remove the log on the right hand side, because log is the log of base 10. Remember, log is log of base 10. Log is really important topic, and I'm thinking to make a separate video of only discussing log and how to calculate log and these kinds of stuff. But let's see. Okay, so when you remove log, so r naught left, and on the right side whatever number you have, this number goes to power of 10, so 10 to the power 0.1, and then you can use your calculator to figure out r naught. So r naught would be equal to 1.258, and you can make it 1.26. This is r naught. Of course the unit will be Fermi meter or femtometer. This is r naught. Find the value of r naught. Hence, or state the mathematical relationship. So you know that the relation was given as r is equal to r naught a to the power n, the first equation. So relation r is equal to r naught 1.26 a to the power n, and n is 0.31. This is the relation between r and a, and this is the value of r naught. Question number 4. A cylindrical container is made from a transparent material. Two students want to determine the density of this material. The students need to make measurement to determine the volume of the transparent material. The external diameter of the container is approximately 10 centimeter. This is diameter. Student A suggests measuring the external diameter with the meter rule. Student B suggests placing a piece of a string around the circumference of the container and then measuring this length of the string with the meter rule. Explain which of these measurements would have least percentage uncertainty. So of course we can calculate the percentage uncertainty in both cases. So the diameter is 10 centimeter and the student A is using. So for a student A, you can do the calculation. Percentage uncertainty is 0.1, which is the uncertainty or resolution of the meter rule, divided by the measurement, which is 10 into 100. So answer will be 1%. For a student B, for the student B, student B is wrapping a piece of a string around the circumference. That means the length of this string is the circumference. So circumference C is pi into D. Remember, circumference C is in fact 2 pi r. If you remember, this is the circumference, but 2r is the diameter. So circumference can also be written as pi into d. Circumference is pi into d, or you can say diameter is 10, so 10 pi. This is the length of the string that the student is going to measure, and the resolutions will be same. So percentage uncertainty will be 0.1, which is the resolution of meter rule, divided by 10 pi multiplied by 100, and the answer will be 0.318 or 0.32%. Clearly, student B has a less percentage uncertainty. This is the conclusion you will have to write. I'm not writing here, but you will have to say that the percentage uncertainty in the calculation of a student B is smaller or less. So that's what you need to say, which one has a less or least uncertainty. So 0.32 is the student B has a least percentage uncertainty. Part B, the student decide to use a string to determine the circumference of the container. They measure the thickness T of the string using a micrometer screw gauge. Thickness T from micrometer screw gauge. Explain two techniques that could be used to make sure this measurement is as accurate as possible. So we are using micrometer screw gauge and we are measuring very small thickness. Generally, micrometer screw gauge, 2 points or 2 things are there. We have to take care of the zero error. If there is, generally there always be some zero error if instrument is not new. If it is used frequently, then there always be a zero error because this is a quite sensitive instrument. So we take care of the zero error to find the correct reading. And more, in another important thing, when we measure the diameter of a wire, or in this case a string, so we measure diameter from different orientation, from different places, so that we can use the mean value to improve our result. So multiple reading from different orientation and zero error. The following measurements were obtained. This is thickness T, 2.15, 2.06 and so on. Calculate mean value of T in millimeter and its uncertainty. Mean value of T, we are given data set. Mean value is we add them together and divide it by 5. So you add them together, 2.15 plus 2.06 plus 2.13 plus 2.08, and then divided by 1, 2, 3, 4, 5, divided by 5. And all numbers are close to each other, so we don't need to ignore any anomalous result. All are okay, divided by 5. So your answer will be 2.104, or the mean T will be 2.10. millimeter. Regarding the uncertainty, so uncertainty delta T will be, I did not show this working, so you have to show this working here. And delta T is uncertainty, which is range divided by 2. So range is highest minus lowest value. So 2.15 minus 2.15 minus 2.06 divided by 2. So the range would be 0.09 divided by 2, 0.045. So 0.045, or you can say delta T is 0.05. Yes, 0.05 millimeter. This is your uncertainty. The circumference C of the container can be determined using the formula C equal to x minus pi into T, where x is the length of the string around the container. Calculate the value of C in centimeter. X is equal to 25.8 centimeter plus minus 0.2 centimeter. We need to find C. So C is x minus pi T. So C is equal to x. X is so x is C is equal to x, 25.8 minus pi 3.14 into T, and T is the thickness. So T is 2.10, but remember this is in millimeter, so you need to convert into centimeter divided by 10, 0.21. So pi into T, 0.21 centimeter, because we need to give answer in centimeter. So you solve this, so C would be equal to 25.14 or 25.1 centimeter. This is the circumference. Show that uncertainty C is approximately 0.2. So we need to find delta C. In this case, C depends upon x and t, and both are subtracting. If quantities are only subtracting or adding, then their uncertainties are always added. So delta C will be equal to delta x plus delta t. So delta x is 0.2 plus delta t is 0.05 millimeter, but 0.005. So you can say that 0.205 centimeter, which is approximately 0.2 centimeter. This is accurate uncertainty. The volume V of the transparent material is given by V is equal to C square L 4 pi minus VI, where L is the length of the container and VI is the internal volume of the container. Determine the V in centimeter cube and its uncertainty. L is given by this and VI is this. So first we calculate the value of V. Then we talk about uncertainty in later on. So let's calculate V, which is a straightforward calculation. You just put all the numbers here. So V would be equal to C square, and C is 25.1. So 25.1 square into L. L is the length. 19.9 divided by 4 pi minus VI. VI is 810. So when you solve this, the left hand this term is 997.7 minus 810, and then finally V would be equal to 187.7 centimeter cube. So this is the volume V. Now let's talk about the uncertainty. If you see the formula, V is equal to C square L over 4 pi minus VI, and C has uncertainty. We have calculated, if you recall, C has uncertainty. C has 25.1 with uncertainty of 0.205. And then L has uncertainty. VI also has some uncertainty. So all have, but so that means uncertainty in this term is added uncertainty of VI. In fact, C square L over 4 pi, this is external volume. I cannot explain here because we do not have time, but C square L over 4 pi, this is external volume. So external volume minus internal volume gives exact volume of the cylinder. So first this external volume, you can give symbol. Let's say VO, or outer volume. So V is in fact VO minus VI. That means uncertainty in delta in V, which is delta V. Delta V must be equal to delta V naught plus delta VI. This is VI. Here, VI. Because we have addition or subtraction of two quantities here. So the thing is, first we need to find delta V naught. Delta V naught is the uncertainty only in this term. So delta V naught would be equal to, this is C square, so 2 delta C upon C plus delta L upon L into V naught. This is the uncertainty in V naught or outer volume. So twice of delta C, and delta C is 0.205 in the previous slide, and C is 25.1. I forgot, I just used a wrong bracket. This bracket must be here. So this 2 is multiplied with only delta C by C, not delta L. Plus delta L is 0.05 divided by 19.9 into V naught, and V naught is the volume of only outer volume, and outer volume we found 997.7. So 997.7. And once you solve this in your calculator, so delta V naught would be equal to 18.8 centimeter. Finally, delta V is equal to delta V naught. Delta V is equal to delta V naught plus delta VI. So 18.8 plus delta VI, and delta VI is 5. And then this is 23.8. So delta V is 24 centimeter cube. This is the uncertainty in the volume. So this is the volume, and this is the uncertainty in the volume. So basically you can write the volume V is 187.7 plus or minus 24. E. The table shows the densities of some common material used to manufacture this type of container. Only borosilicate is safe to heat directly with the Bunsen burner. So material soda glass density is 2.52, borosilicate 2.23, perspex is 1.18. The mass of the container was measured 463 gram plus minus 1 gram. Deduce whether the container is safe to heat directly with the Bunsen burner. So the idea is, there are many methods to deduce the result, but one method that is coming right now into my mind is we can find maximum possible density of the container and minimum possible density. So remember, density in general, mass over volume. So this density will be max if mass will be max divided by volume will be minimum. And the minimum density will be mass will be minimum and volume will be maximum. So let's calculate the maximum density. So maximum density of the container. So mass should be maximum. So 463 plus 1. So 464, this is the maximum possible mass divided by minimum volume, because volume is in denominator, so it should be minimum in order to have a greater fraction. So minimum volume, and I gave you volume was 187.7 plus minus 24. So minimum is 187.7 minus 24, which is 163.7. So the density would be equal to 2.83 gram centimeter cube minus 3. And minimum density would be minimum mass 463 minus 1, 462 divided by maximum volume. So 187.7 plus 24, which is 211.7, which is equal to 2.18 gram centimeter cube minus 3. Now clearly you see that minimum is 2.18 and maximum is 2.83, and we have borosilicate and soda glass. Both material densities are within that limit. So the container made by that particular plastic or whatever the material is, it can be a soda glass or a borosilicate. So we are not sure that whether it is safe to heat or it is not safe to heat, because it can be borosilicate, it can be soda glass. So on the basis of this calculation, this is our conclusion. Thank you very much. I hope you understand. If you have any doubt, any problem, any question, please let me know in the comment section. I will try to give you answer as soon as I can. Thank you very much. Have a nice time.